Okay, moving on to the MCQs for question 8. Right, the use of the data booklet is relevant to this question. So we have a hydrogen-oxygen fuel cell. So in this case, hydrogen, okay, must undergo oxidation. Oxygen gas, because of the oxygen state 0, will have to undergo reduction because the common oxygen state of oxygen is -2 and 0. So since if it's 0, the logical thing is to go to -2. For hydrogen, because common oxygen state of hydrogen is 0 and +1, so it means that hydrogen must undergo oxidation. So in this case, this will be your anode, this will be your cathode. Take note that we are doing this in alkaline medium. Okay, so you need to choose your data booklet equation. So in this case, we can take a look at half equations. So I need to choose oxygen in the alkaline medium. So this is very similar to what we have discussed in question 6 of the earlier tutorial. This will be the equation we choose for oxygen, alkaline medium. For hydrogen, this will be the equation we choose. Right, similar concept to what we discussed in question 6. So let me just zoom out a bit so you can see two equations. +4 and -0.83. So in this case, we call oxygen gas, hydrogen gas. So this is your E naught ox, this is your E naught reduction. So 0.4 minus -0.83, you get positive 1.23 volts. Okay, so the E naught of the oxygen fuel cell, oxygen electrode, alright, so in this case, it will be 0.40 volts. And since this is where oxidation occur, alright, since the hydrogen gas cell X is the anode, it's going to be the source of electrons. So electrons will go from X and come to Y. Okay? Okay, moving on. We go on to question 9. So question 9 says that we now have some acidified ketane peroxide, hydrogen peroxide, H2O2. And then we have some potassium iodide, Ki. Now, from the context of the question, alright, just based on the equation given, I need to focus on I minus. So in this case, I minus is over here, H2O2. Alright, you can see over here. So in this case, I minus, the only logical reaction that must happen must be your oxidation. It forms I2. So I minus to form I2. So this is oxidation, which means peroxide must therefore undergo reduction. So which means I must choose an equation in which peroxide must be reduced. So I must choose peroxide on the left-hand side of the equation in order to undergo reduction. And then you look at the E naught values. This is your E naught ox, E naught reduction, because we said that earlier, I minus is a starting reactant. I minus must undergo oxidation, therefore this is assigned E naught ox. And H2O2 therefore must correspondingly undergoes reduction, and therefore from this you can work out the E naught value, 1.77 volts minus 0.54 volts. You cannot be positive 1.23 volts, which means more than 0. It's going to be a feasible reaction. So you will end up producing I2, so solution will turn brown. The question is there effervescence? So you can see the product, we only have I2 and water, so that's without effervescence, and that's why the answer is B. Okay? And that's it for question 8 and 9.